Look around your classroom right now. The desk, the wires in the ceiling, even the pencil graphite. Everything belongs to one of two great families of elements, metals or nonmetals. Why does this matter? In your exams, questions on physical and chemical properties of metals and nonmetals appear year after year, and in life, choosing the right material for a job, from building bridges to designing computer chips, depends on understanding these two groups. Let's start with intuition. Imagine metals as the social butterflies of the element world. They love sharing electrons, conducting electricity, and sticking together in strong bonds. Nonmetals, on the other hand, are the keepers. They hold onto their electrons tightly and prefer forming molecules rather than giant structures. Formally, metals are elements that tend to lose electrons to form positive ions, are typically solid at room temperature, shiny, malleable, ductile, and good conductors of heat and electricity. Nonmetals are elements that tend to gain or share electrons, exist in various states, are dull in appearance, brittle when solid, and poor conductors. We call them insulators. Let's work through a quick example. Suppose you have iron, a metal, and sulfur, a nonmetal. Iron is shiny gray, conducts electricity, and can be hammered into sheets. It exhibits malleability. Sulfur is a dull yellow powder, does not conduct electricity, and crumbles when struck. It is brittle, confirming it's a nonmetal. Now, two common mistakes students make. First, don't assume all metals are magnetic. Only iron, cobalt, and nickel are. Second, don't think all nonmetals are gases. Carbon and sulfur are solid nonmetals at room temperature. Here's a real-world connection that'll surprise you. Your smartphone screen uses indium tin oxide, a metal compound, for its transparent conductor, while the chip inside uses silicon, a metalloid that behaves like a nonmetal in many ways. The Statue of Liberty is copper, a metal that turned green due to chemical reaction. Metals react with oxygen and water, forming oxides and hydroxides, while nonmetals like chlorine disinfect our water by reacting differently. So your cheat sheet. Metals lose electrons, conduct, and are malleable. Nonmetals gain or share electrons, insulate, and are brittle. Remember these properties, test them with simple observations, and you'll never confuse the two families. Once you master metals and nonmetals, you unlock the next level, understanding ionic and covalent bonding, which explains how these elements join hands to build every compound in the universe.